In this lecture, we're going to take a look at the useful notion of an associative array. The other topic here, hash tables, is frankly a concrete way to implement associative arrays. Here's how one of those approaches would work. If we took the first three digits, 214, the middle three digits, 365, the last three digits, 879. If we added those together, we'd get 458. And then reading that modulo 1000, in other words, just taking the last three digits of that, we'd get the index 458. Okay, so under this hashing scheme, the key 2143658879 would get hashed to the index 458. Okay, so that is an example of a hash function. A hash function takes a key and converts it into an index into the array. And there's lots of different ways to come up with hash functions. Choosing a good hash function is something of an art, and different data sets with different keys might benefit different hash functions. We will not invest any time in the subtleties of this. One thing that we should definitely discuss, though, is how big should we make the actual array? In the example, we made the actual array size 1000, and therefore we required a hash function that converted 9-digit key to a 3-digit index. Okay, but there's nothing sacred about that number 1000. We could have used a bigger array or a smaller array. So you probably see this already, but there are some trade-offs here, right? If you make the array larger, then you'll wind up having more wasted space. You'll have some indices won't correspond to students at all. Okay? The extreme case of that was what we started with, where we had an array of size 1 billion, and so most of the array was just wasted, right? You make the array too big and you're going to waste space like that. Okay? And then I think you see this just as clearly. If you make the array too small, well, that's going to increase the number of collisions that occur, and therefore each of the linked lists involved will wind up being larger. So let's say, somewhat extreme. Suppose we made the size of the array, 5, right? And then our hash function would have to turn a 9-digit student ID number into either 0, 1, 2, 3, or 4, right? And then, well, there'd be a heck of a lot of students that would hash to, say, the number 2, right? A lot of students would have IDs that hash to 0. A lot of students would have IDs that hash to 1, also to 2, also to 3, also to 4. Okay? So we'd have a very small array of pointers, but each of those pointers would now point to a fairly long linked list. Okay? Probably a very long list. So that, too, is a bit of an art. Okay? Deciding on how big to make the actual array is definitely part of the art of hashing and hash tables, and of course choosing a hash function that works well is also part of the art. Okay, there is nothing sacred about integer keys. Quite often, people use associative arrays and hash tables based on keys that are not integers. Okay? It's very common to see hash tables and associative arrays where the keys are character strings. Okay? But if you think about it, this really doesn't complicate things much. You're probably well, before I get onto that, so now let's imagine that we want to stay with the student record example, but that we're going to use student names instead of IDs as keys. Okay, so we'd like to have an associative array where we could index, into that array using a student's name, Bob Smith, and the associative array lead us to Bob Smith's student record. Okay, is this possible? Can we hash character strings? And the answer is yes. That's actually very easy. If you think about it, you may very well be aware already that, character data inside a computer, like any data, is stored as patterns of zeros and ones. And you can think of each character as corresponding to a number. Okay? The standard ways in which character data corresponds to numbers, the old-fashioned approach is ASCII. The newer, sort of jazzed-up version of ASCII is called Unicode. But in either case, each character corresponds to a number. That idea is already built into your computer. So, for example, the letter capital A would correspond to the ASCII value 65. Okay? Well, it's trivial then to convert characters to numbers. Okay, and, well, what is a string? A string is just basically a list of characters. And you can think of these juxtaposed characters as being like juxtaposed numbers. You can think of a string then as really just corresponding to a long number. Okay, maybe a really long number. And okay, if we can hash numbers, and we've been doing that, we were hashing 9-digit numbers earlier. So now all we have to do to hash strings is think of the string as a number, and now we're set. Okay? If we can hash numbers, we can hash strings. I mentioned earlier Perl. I guess that was the first language that I learned hash tables at a practical level. Because Perl basically, well, it uses hash tables to implement associative arrays, and that's a popular aspect. That's a big part of the Perl programming language. Okay. I say again, not all languages implement associative arrays using hash tables. Another very real possibility is to implement an associative array using binary search tree. Okay? You use the key to look up data in the binary search tree. The data is ordered, following the parent-child relationship rules. The data would be ordered based on the key, as we discussed when we did binary search trees. And then, the rest of the value could also be stored there. Okay? So you could have a binary search tree of student records, and they would be organized according to the student ID number, for example. Okay, C++ actually is a good example of a language that implements associative arrays using binary search trees instead of hash tables. Okay, the time has come once again for us to delve into some actual code. So as usual, I ask you to take a look at, download and examine and run and play with either the Java version of my hash table code, or the C++ version. The hash table works very much like we've been describing it. An array of pointers, and the pointers point to linked lists. Okay, but there is a little bit of a twist here. Instead of having keys that are 9-digit numbers, integers, what I'm actually working with for keys for the student ID, each student ID is actually an array of 9 characters, right? So each of those characters is a digit character, okay? So technically, this is different than having, a long integer. It's actually a string now of characters. Each character is a digit. Okay, but the hash function I'm using is this one that was described earlier. You take those 9 digits, you split them into 3 groups, the first 3 digits, the middle 3 digits, and the last 3 digits. And then using each of those 3-digit combinations, basically convert that to an integer, produce an integer corresponding to those digits, and then take those integers, add them together, and like we did before, reduce the sum modulo 1000. Okay? So, say again, we're taking a key that's actually 9 character digits, and we're hashing it down to an integer value that's between 0 and 999. So there's a class in the code called student hash table, and that an object from that class represents the entire hash table. There's also a class called student linked list, and an object from that class represents one of the linked lists that we discussed as part of the hash table. And there are also objects, well, there's also a class called student, right? So an object from the class student is basically a student record. There's a method for adding a student to the hash table, and it works as follows. So the name of the function, the name of the method is insert student. And I need to be clear here that this is a method from the class student hash table. So in other words, this method is supposed to act on a student hash table object. And again, its purpose is to insert a new student record into the hash table. Okay, so it has a parameter of type student. So you can pass a student record object to this function. We're looking at the C++ version. The Java version would have the word static in there as usual, but really it's the same thing. Also, if it would be better in C++, the C++ version really should pass by reference, but let's ignore that. So anyway, you pass this thing a student record, and it's going to insert it into the hash table. Let's look how it does that. First, it grabs the ID number for the student, which, as I said, is actually not an integer value. It's actually an array of characters. Okay, and we're going to hold that locally inside a variable here named ID. Okay, ID is an array of characters variable. Okay, then we call a function named computex and pass it this ID, and it's going to return an integer that we're storing into index. Okay? Did you guess it? Hopefully you guessed it. This is the hash function, right? Compute index is the hash function that is converting a key into an array index. Okay? And in a little while we're going to look at the details of this hash function. Okay? But for now, just trust that it correctly hashes to the right index. Go on here to use that index to look inside the array that's maintained by the hash table, and then that array is actually, well, under the hood it's really a pointer that points to a linked list, but we are actually using the linked list object here. So, okay, this may seem a little confusing. The array bracket index in this code is the appropriate linked list that we need to insert the student into. So we take that linked list and we call the linked list method named insert student. Okay? This is a different method. Insert student here is a method that acts on a linked list. And anyway, it takes the student that we want to insert into that linked list, and that's what it does. It inserts that student into the linked list. Okay? You can check over all the details of the code. Okay, there may be some confusion here as to, we were previously saying, well, the array is going to be an array of pointers. It really doesn't matter. You either have an array of pointers in C++, that would be very common, or you have an array of linked list objects. Okay? The important thing is to, index into the array in order to get your hands on the correct linked list, and then you can insert the student into that linked list. All right, let's look at the code for the hash function. And this uses some standard old-fashioned C trickery. Let's remember that the key, it's a good thing. It's a good thing to get used to this kind of coding. All right, where maybe I could have used a long integer for the key. Long integers, I believe, will let me go up to size 1 billion, but maybe not. I'm a little forgetful about that. Anyway, I avoided that issue by making the key an array of 9 characters rather than an integer or a long integer. Okay? So let's see how this guy is going to convert that 9-character key into an index into the array. Okay, notice where it says ID bracket 0 minus single quote 0 single quote, right? That's taking the first character in the key and producing the corresponding integer value, so that if that character was the character 3, single quote 3, single quote, well, single quote 3, single quote minus single quote 0, single quote is actually the integer 3. I'm not sure, of course, I'm not sure how used to ASCII code you are, or Unicode, but this is how it works, right? The character 3 is not the same thing as the integer 3, but if you take the character 3 and you subtract the character 0, which is legit, you'll get the number 3, right? Okay, so now I'm dealing with a number. So pretend that first character in the key is 3. Then ID bracket 0 minus single quote 0 is going to be the number 3. That gets multiplied by 100, right? And then I add 10 times the value of the next character. And then I add the next character. So let's pretend that the first 3 characters are 3, 7, 5. Then we're going to end up here with 3 times 100 plus 7 times 10 plus 5. 375. The integer 375. Okay? That integer 375 gets stored in the variable first. Okay? And then similarly, the integer corresponding to the 4th, 5th, and 6th, the middle characters, the integer corresponding to the middle 3 characters would get stored in the integer variable second, and then the integer corresponding to the last 3 characters in the key would be computed. That integer would be stored in the variable third, right? Okay, and now it's just a matter of, like we did before, adding those 3 integer values together and reducing it modulo 1000, okay, so as to guarantee that we have an answer that's between 0 and 999, and that's it. That number is what's returned by this hash function, something between 0 and 999. So here it is all again, just If you're not quite clear about what I said, then take a look at this. So that's it for our investigation into hash tables and associative arrays. Well, let me say that's it for the lecture. I will once again strongly encourage you to spend some time with either the Java code or the C++ code and try to figure out how it works.